So, good morning everybody. I'm Daniel and I work for Classic 6, and today I have a presentation: how the hell do I run microservices with Docker in production and will it scale? So I'm the developers advocate at Classic 6. So what's a developer advocate doing? So basically, if you look at our company or other companies, you do like DevOps, UX and business, and the developer advocate is a little bit in the middle. I'm a developer myself. I have a background in Java and in Ruby, and nowadays I program in Ruby and in Golang. And I have 2 slides what Classic 6 is doing, and then that's it of the vendor talk. So Classic 6, what we're doing, we provide a platform running Docker in production on any cloud or your own service on premises. And what we're doing, we take your code, the Git repository or your Docker images, and then we'll have an orchestration engine which deploys your whole infrastructure on the cloud of your choice. So we basically providing operation tools for developers. And today I'm going to do like 2 things in this presentation. First half of this presentation is about getting the right image. And when you started with microservices and using Docker, the basic ingredient is your image. So we're going to talk about that. And then the second half, I'm going to talk about how do you run those things in production and what do you need. So before I joined Cloud 66, I worked in the gaming industry and also in the interactive media industry in Amsterdam. Oh, I'm originally from the Netherlands. And a lot of times when we run in the digital department of this creative agency, we have all this. Our customers have all these ideas we want to implement, and we are, okay, so you want something like chat with Ruby, or you want something to do with WhatsApp, you need Python, or you need Java, you need all these nice ingredients, you know. When you go to GitHub, it's like this box of really nice fruits where you can just combine, so you really want to mix and match all these technologies. And before the whole container world, like 3 years ago, it was really hard to mix and match all those technologies. You did a lot of heavy lifting, and when Docker came around and the containerization, I was really happy because that allowed me to mix and match technology. And but then I picked up the whole containers things with Docker, and I felt it like this. I was like, okay, so you have this concept of a container, but how does that fit in my IT landscape? How do I use it? And this is if you go to the Netherlands, if you ever been to the Netherlands, we have a big harbor in Rotterdam, and if you enter Rotterdam harbor, you find this sculpture. And I felt like this. I was like, okay, so I have this container. So where do I start? Is this a VM? No, it's not. Do I run one process? Do I run 2 processes? What do I have to do with this container? Well, how does it fit? And so basically. Who's running Docker in production, by the way? Is there someone? So we have 1, 2, 3 people who already played with Docker. Good ones. Who never used Docker before or container technology? Okay. Okay. So my presentation today is a bit of a high over because I didn't know what kind of experience with microservices and container technology. So probably a part of this presentation you probably all know, but some parts may be new, so we'll just see how it goes. And getting back to this image, so learning new technology takes some time and some skills, and when you are starting to learn, for instance, container technology of microservices, you basically have time and skills, and this is a little bit of a learning curve you get when you're starting with Docker. So basically, you have this line, and on the bottom, you do something like hello world, right? So you're right here. So if you never used container Docker before, you're probably here. You don't know what kind of skills you need, because in the end, you want to run in production. And you start learning, you're learning some skills, and basically when you pick up the Docker 101s on the internet, you create like a Docker file and all that stuff, and you're getting a lot of skills. So you think you know what you need to run in production, but you probably don't know. And then you see this gap. I mean, this is a really nice metaphor here because I'm standing here on stage. So you're learning Docker, and then over there is running in production, and I'm standing here like, okay, so how do I get there? I mean, there's a gap here, because there's a lot of things you have to think about running things in production, especially with containers. And so what I'm going to do today is try to help you not to fall off this stage, but create a bridge that you can go faster into production with containers. So basically, you don't want to end up like this. So you have your minimal lovable service on top, and if you don't navigate, if you don't have that bridge, you probably will fail implementing Docker and microservices in production. So how are we going to do that? So first, we're going to talk about how to create the right container image, and the other one is how do you run containers in production. So let me take a step back. So I created this timeline here. So back in the days when we deployed an application, for instance a Ruby application, so the time between development and operation, there's a lot of time. You have to spin up a real server. I mean, it's a long time ago, of course, when you have like a rack and put it in a rack and do all the, operation systems and networking and all that stuff. So that took a lot of time to run that application. And then we had the whole cloud VM stuff where you can just, spin up a VM somewhere in the cloud. So the time between, mixed match technology, run it somewhere, you see that the time is getting closer. And with containers, if you're not familiar with containers, what containers is doing is basically isolation on your box. So basically, you're sharing the OS, you're sharing your binary libraries, and it's all isolated by namespaces. It's really, with C groups and all that stuff. If you're Linux, if you're into Linux, it's quite hard to understand that, but Docker creates an abstraction layer to that. So you see that we are basically have a lot of, containers running on the system, and you see that when I'm using all kinds of technology, the time between development and operation is getting closer. And this is quite interesting because if I showed this slide, what you're going to see is that between development and operations, when that collide, you see that with containers, the development and operations is getting really, really close. Because the thing is, when you look at how Docker and containers are organized, they say build, ship, deploy. So basically, you start with your service on top. That's your programming code. Then you build this image, which is your Docker file. And basically, your Docker file is your description how to run your service. But that Docker file, that's operation stuff. Because it describes what kind of OS I'm running, which kind of service what kind of libraries I need, all that stuff. So what you're seeing is over there you need collaboration between, in your team, because we're all responsible for running that thing in production, and then you ship it as a container on the Docker engine, and eventually you want to deploy it on the platform. So how do you get started? So this is what I called the containerization machine. So basically, on top you have your code, and you have this machine creating those images which are the base of your services, of your containers running. And the thing is with this whole containerization, this is one process you have to do when you want to start with microservices and containers, is this one. So on top, if I put in like all this code, but it's shit. So you're putting all some shit things inside your images, building the images, then you get this, smiley shit thing. But eventually, in production, it's still shit. So it's really important when you start using containers and microservices using container technology, is that you take care of this. So shit in is shit out, also in production. If you don't get this right at the start, you're screwed. So basically, what they say, you can't polish your term. So shit, you can't make shit better than with this technology. And what I see a lot of times, it didn't have time to create a slim image, so I created a fat one instead. And this is, I'm not going to say this is a bad thing, but if you are learning containers, you're probably going to do, I want to do everything in one container. So I'm treating a container as a VM. So you want to create this really big image to start with. but that's not the right way to do it. So basically, if you want to create your minimal lovable service, you want to create your minimal lovable image. And it has to be same on development environment, test environment, staging environment, and production environment. And if you're familiar with keep it simple, this is the same thing. I say, keep images slim, secure, speedy, stable, and set. So I'm going to dive into all this parts which you need to think about when you want to create this image. So let's start with slim. So slim it's not really about getting the least megabytes in, but it's getting things out of it. So basically, if you are familiar with Docker and containers, you start with this base image, and sometimes you start with Ubuntu. And Ubuntu is like 150 megabytes, and they have a lot of packages there, but you don't need it because you're running one process in a container. You don't need all that stuff. So get rid of all this compile time dependencies you need, remove packages you don't need, and of course also run statistics to your image. With Docker, you can do like Docker history and then your image, and you can see all the layers which are used by this Docker container. So security. So take care of that. So remove all the secrets. The thing is, when you look at how containers are organized, they're using like a layered file system, meaning that you can delete layers, but the layers are still there. Because it is because, for instance, if you put like a secret inside your image and you remove that image, that layer is still existing. So you need something to really get rid of that layer. So you squash the image so that the secrets are not there. And also run the image with the right user ID. With the latest version of Docker 1.11, also the usernames are namespace, so root in the container is not root on your system, but before that, root on your container is also root on your system. So you have like tools where you can run against your container to see if you have any security breaches there. And of course, test your image. Also speedy, so we want speed. So things like optimize your code. What I'm seeing, if you look at a lot of like microservices and Docker 101 tutorials on the internet, they just want to learn you how to create a Docker file, but they're not talking about performance. So you're running, for instance, an application server which is not built for production. So you basically, if you are building an image, you are building an image for production. So make sure your code is optimized for that. And also, if you're using an application server inside your container, it's also optimized. So one process per container, and also do some load testing. Because you really want to know how it performs on the load. Because if you create this image, this container, and there's a lot of traffic coming in, you need to know how much memory it's consuming, what the CPU load is, so that you also can scale those things on your system. Stable. So when you're creating Docker images, sometimes you create a base image, and it's really easy to say, okay, just get me the base image, the latest. But you never know what the latest is, so you have to lock in those versions. So what you want is when it runs on my machine, it has to be the same version running on my coworker's machine, or run it in production. So it's really important to lock the image versions, also the runtime versions, and tag your image properly, and also with your team decide how you do your logging. Because when you are going for microservice architecture, for instance, you've got a lot of different services running around. Maybe you have like from one image you have 1,000 services. Where do you find where one running container goes mad? You have to really look into this log file. So you really have to come up with a good strategy how to do logging. And then the other thing we should take care of is set or immutable. So probably if you are going to start with Docker, you try to do it all on your local machine, but your local machine is not the same as a production environment. So take care of that. So make sure that you use volumes wisely. So if you're just running Docker on one box, you're fine because the volumes are not changing. But if you're running Docker in containers in a cluster, maybe some nodes can fail. So what are you going to do with the data? So take care of that. So don't use database inside an image. It's hard to scale in production. And of course, use external services for persistency, so to make it more resilient. Okay, so now what? So now I'm standing here, with my images, with my containers, ready to run that in production. But like these fishes in Finding Nemo, they're like, okay, so we escaped, but now what? And so we basically need some kind of a platform. So at Cloud 66, on average, we manage like 5,000 servers running Docker in production for over 700 customers. So I researched how our customers are using microservices and Docker in production. So I'll show you some numbers, how people are using Docker right now. So before I go talk about the platform, so let's see this. So 70% is using this. It's called monolith containerization. So basically what they're doing is they take the monolith, put it in a container, and run it in production. So basically, this is fine with me, but there's no sense of using containers because you can also use a VM. So basically, they're treating a container as a VM. But this is all part of the learning curve, so it's not bad. This is what I'm seeing right now. And then you see this next step, you see like API first approaches, where they run two containers, like one front end and an API, and still using fat images. And then we're getting to the juicy bit. This is all part of breaking down the monolith into microservices. So we see 6% is in this process of splitting monolith into microservices. What you're seeing is that people have like a front end, which is still like a big fat image, and then you see that the API, it's built on this GIS principle, and then it just, for scaling, it will just run 6 containers, or if they need more capacity, just to scale up the containers and even more, communicate with a database, and also using like workers as containers. So this is already, you see that there's something going on here, and then about 4% is using microservice architecture, where, services are talking to each other using message queues, databases, or API endpoints, and all of this infrastructure. And so, how do you run your minimal lovable image or service? Well, you need a platform. Because I created this image yesterday because I was, okay, so like Docker and containers, they only allow you to run a container, but they don't provide you with the tools running in production. If you want to run your service in production, you need a lot of things. You need security, data management, orchestration, lifecycle, discovery, monitoring, scaling, scheduling, all those things. So basically you have your microservice, but look what is all around what you need. And basically it's all the things you need in production if you're running on VM or something else. I mean, there's still the stuff you also need. But it shows you that running in production is not that easy. So let us dive into all these topics and just see what's needed to running your microservice in production. So we're talking about lifecycle. So lifecycle meaning things which are, when you have image guidelines for your team. So you really need to know where is that image coming from. So we create a base image. So everybody using the same base image. So your team is using the same principles. You need a workflow. How do you create your images? How do you test those images? How do you put them to production? So your platform has to support the whole lifecycle of your software, but also your workflow. And also, which is important, from design to production, you need to mimic your production environment on your local machine. You want to basically run your little microservice on your computer like it's your production environment, and also do the integration tests on your local machine and test heavily. Orchestration. So orchestration, and if you go to like DevOps conferences and all that stuff, everybody's talking about orchestration. And orchestration is basically just, for me, it's about, creating the services, do the load balancing, make sure that the servers are isolated. So it's also really important. So you have a couple of approaches. One of the approaches which you say, okay, I have a lot of servers in my data center. I provide a layer, and it's just one big, container computer. But the thing is, then you abstract away where your containers are running, But sometimes you also want to isolate those services. Maybe you don't want to have like one service running on the same computer, because still containers are isolated by namespacing. But if something breaks out or dies, you have a problem. So you also need things like isolating of services and self-healing. If a node goes down, where are your services going? All the things you need from a platform. Discovery, service discovery, really important, especially when you are, if you're running like one service, like the monolith thing, you don't really need service discovery, because what do you discover? Only your database. But if you're going for microservice architecture, you really want to discover your images, your services, and your data source with minimal code. So what you're seeing right now is that most platforms are using DNS-based service discovery, where you can just say, okay, I want service A has to be communicated to service B. Just give me service B. Where is it? And you just pop in the DNS name, service B.local something, and just gives you back the IP address of the overlay network. And service A doesn't care if it's talking to service B, it's running in that container or that container. I mean, the platform has to take care of it. I just want to consume that service there. So it's really important to have a good discovery strategy. And also when you are deploying new containers, you're switching from version 1 to version 2, you want to make it as zero, you want to make zero downtime deployment. So you want to have, I have a new version, the version goes to your platform, will spin up, it do the health checking, and knows, okay, this new service is up and running, and then your service discovery system will switch the traffic to the new services. So you need that from the platform. And also scaling up and scaling down, all that stuff. So also scaling and scheduling. So meaning when you start your microservice architecture in your containers on your cluster, where do the servers run, and when a physical server fails, where do the scheduler put those somewhere else? And if you also have containers running which consume an amount of memory and CPU, if you run out of capacity, will your platform alert you that you need to scale up, add more servers, or do auto-scaling when your platform just spin up new servers in AWS or anything? Also things like failover groups. What's happening when your whole cluster goes down? Can you redirect your traffic to another cluster somewhere in another data center? Or do things like running services on region A and serving region B, and is there a network there? So all these things you need to think about if you run Docker in production at scale. Data management. So what about data? So you need, it's all regular stuff, right? So if you run a database, you need backups, you need restores. But how do you go to do that if your database is running in a container? And where does it sit? Where does it put the data? Somewhere in a volume attached? How do you do the backups? How do you do the restores? So it's really important if you're going for microservice architecture and running containers in production, that you choose the right platform to do this. If you are going to use databases as a service somewhere else, you can just put it away. But if you manage your own databases in your own Docker system, so take care of those things. Monitoring, important. So, especially when if you run just one container, you just have the log files and you monitor your one container, you're fine. But if you have like 1,000 services running, then you have to collect all those logs, make sure that you can, analyze those logs, see what's going on when servers are dying and why. So logs and monitoring is really important also for debugging your containers in production. So you need something for that. And also security. So there's a lot of things you can do on your machines running. So like firewalling, intrusion detection, but also things, are services allowed to talk to other services? Do you make sure that one service can access the other one, so you can isolate those services? Failover groups, firewalling, and also verification of images. So when you start using Docker, you're probably putting some images from the Docker hub. But do you know what kind of image you are pulling? Who creates those images? You can, for instance, if you try to get an image, is it signed by who? Who's responsible for that image? And if this image is just changing, does it contain vulnerable code? And so a lot of customers of ours are using like their own private image repository, and they're building their own images from scratch, and also sign those images so they know, okay, this image is created by Daniel, or this image is created by Robert, or whatever, so that you really know what's running on your production system. So also be careful when you're putting images you don't know in your production environment. So make sure that you isolate those. And so basically, when you get DevOps right, so you implement all the, your team, the culture, and the right microservice architecture, and also creating the right minimal lovable image, and having the right platform to run containers, you're probably a happy camper, and it's really great to use this technology, and then you can mix and match those technologies. So this is my talk. So check us out. So we provide a platform for running Docker in production on any cloud or on premises. www.classic6.com. You can find all interesting blog posts on our blog. Also, we have an open source project called Habitus. So that's maybe worth noting is that when you're creating Docker images, sometimes you need to, for instance, if you are a Golang programmer, you need like the compile time dependencies. So you put the compile dependencies in your image, you compile your binary, but you don't want to have that in your production environment. So with Habitus, you can say, just compile my binaries, get the binaries out of my image and put them in a new image, the smallest one, like an Alpine, which is like 5 MB image, and then run that thing in production. Or you can do with Habitus, you can pull in your secrets, remove the secrets, and then also squash the image that the secrets are not there anymore. So that helps you with Docker build flow tool. And also we have an open source project called Starter. And with Starter you can run Starter on your existing code base, and it finds what kind of technology you're using, and then it generates like Docker files, Docker Compose to test your containers. And that's for me. So any questions?